Hello dear student, welcome to this session of space analysis in orthodontic. In this session we will focus on space analysis in mixed dentition. Space analysis can be used in both the permanent and during the mixed dentition. During the mixed dentition, the term space analysis is used to describe the method of estimating the amount of space which is likely to be required for the permanent teeth when they erupt. It is important to quantify the amount of the space available within each arch, as the treatment will vary depending on the severity of the crowding. Space analysis or space planning is carried out into two phases. In the first phase, we are going to calculate the space available, and in the second phase, we are going to calculate or measure the space required. Generally speaking, space analysis is a kind of comparison between the space available and the space required. We will end up either having extra space or available and required space are equal to each other, or we may have space deficiency. But remember, in the first step of space planning is to calculate the space available. Measuring the space available can be done by dividing the arch into segments. We can divide the arch into 6 segments, 3 on the left and 3 on the right. So we can measure the distance from the mesial point of the permanent molar to the distal surface of the primary canine, and we have the canine section and we have the incisor section. Also, in some cases where the primary canines are not available, we can measure the available space by dividing the arch into 4 segments. From the mesial surface of the molar to the distal surface of the incisor, and we have the incisors section. On the other hand, measuring the available space can be done by using a piece of wire, by contouring a piece of wire on the line of occlusion. Remember, if the arch are crowded, in this case, the piece of the wire should represent the arch form where most of the teeth are included. Again, remember, space analysis is two-phase. In the first phase, we are calculating the space available. In the second phase, we are calculating the space required. In the second phase, which is the measuring the space required or space needed, we are going to measure the mesiodistal width of the erupted teeth plus the mesiodistal width of the unerupted teeth in order to estimate or calculate the space needed. We have methods to calculate the mesiodistal width of the unerupted canine and premolar. Of these methods are Tanaka and Johnson's method. This method is called the equation method. I will show you an example of how to measure the mesiodistal width of the unerupted canine and premolars. This is the Tanaka and Johnson method. In this method, first step, we are measuring the mesiodistal width of the lower incisors. Here I am giving you an example. So the mesiodistal width of the lower incisors were 5.7, 5.3, 5.2, 5.8. In step 2, we will add all these numbers together. We will ended up having 22 millimeter, which represents the mesiodistal width of the erupted lower incisors, the laterals and the central incisors. In step 3, to measure the mesiodistal width of the unerupted canine first and second premolar in the lower arch, remember we have the mesiodistal width of the erupted incisors and we have an equation. We will divide the mesiodistal width of the lower incisors by 2. For the lower incisor, we will add 10.5 to that number. Here we have 22 millimeter. 22 divided by 2 plus 10.5. We will have 21.5 millimeter. This 21.5 millimeter represents the mesiodistal width of the unerupted lower canine and premolar. To measure the mesiodistal width of unerupted canine first and second premolar in the upper arch. Again, we have the mesiodistal width of the lower incisor. In our example, it's 22. In Tanaka and Johnson method, we have the equation. In this equation, again, we will divide the mesiodistal width of the lower incisors by 2. And we will add 11. Remember, in the lower arch it was 10.5. In the upper arch we will add 11. So we will end having 22 millimeter. This 22 millimeter represents the mesiodistal width of the unerupted upper canine first and second premolar. We have another method which is called Moyer's method or the table method. The steps are as following. We will measure the mesiodistal width of the lower incisors. Please remember, this is just an example. In step 2, we will add the mesiodistal width of the lateral and the central incisor all together. In our example, we have 22 if we measure the mesiodistal width of the incisors. In Moyer's method, step 3, to measure the mesiodistal width of the unerupted canine first and second premolar in the lower arch, we have a table. For our example, the mesiodistal width of the lower incisors were 22. In the table, we will go to 22. Okay. The mesiodistal width of the unerupted lower canine first and second premolar is 21.6. Remember, when we are using this probability chart, so first of all we have a probability chart for mandibular teeth and we have another probability chart for maxillary teeth. For both the maxilla and the mandible, we will go to the level 75%. In our example, the mesiodistal width of the lower incisors were 22. Okay, this is 22. And the 75% of 22 will be 21.6. So, the mesiodistal width of unerupted lower canine first and second premolar will be 21.6. Again, in Moyer's method, step 4, to measure the mesiodistal width of unerupted canine first and second premolar in the upper arch. We measure the mesiodistal width of the lateral and central incisor of the lower teeth. Remember, again, it's in the lower teeth. And in our example, it is 22. We have another probability chart for the maxillary to predict the width of the maxillary 3, 4, and 5. Again, in our example, the mesiodistal width of the lower incisors were 22. We will go to the 75% level. So the mesiodistal width of unerupted upper canine first and second premolar, or the estimation of the mesiodistal width, is 22. Dear student, we have another method which is the radiographic method. In this radiographic method, the steps are as follow. We will measure the mesiodistal width of the D on the cast or on the mouth, and mesiodistal width of the D on the X-ray. This radiograph could be periapical radiograph or it could be OPG radiograph. In our example, the mesiodistal width of the D were 8.5 millimeter. If we do our measurement inside patient's mouth, and the mesiodistal width on the radiograph was 9.5. Remember, this is just an example. We measured the mesiodistal width inside patient's mouth, it was 8.5, and on the radiograph it was 9.5. Step 1. Step 2, we will divide what's been measured inside patient's mouth by what's been measured on the radiograph. We will get a number. In our example, it is 0.89. This is called correction factor. So it was step 2. In step 3, we are measuring the mesiodistal width of the unerupted canine first and second premolars on the radiograph. In our example, it will be equal to 9 plus 7.5 plus 7.5, and the total is 24. Step 4, we are going to estimate the true width of the unerupted teeth. We have the sum of the mesiodistal width of the canine premolars on the radiograph. In our example is 24, and we have the correction factors we measured previously, as you remember. So 24 multiplied by 0.89 will be equal to 21.36 millimeter as the estimated width of the unerupted upper canine and premolars. Thank you for your attention. I hope this presentation or this lecture is useful, and later on you can do your space analysis in mixed dentition. Thank you very much for your attention. See you in another session.